All right, let's go ahead and start talking about bonds. We're going to talk about how atoms bond with each other and really the different types of bonds that they make. Now, today we are going to focus on one type of bond, but before we do that, we are going to talk about the two types of bonds that we're going to talk about a lot. There is a third one, but we will talk about that later. But the periodic table is made of two types of elements. We have metals and non-metals. All right, so you can write the word metal there. So we have metals and non-metals. And it's going to be really important to recognize the difference between the two. Now, if you look here on the periodic table, everything that's, so we have this staircase here, Everything that's to the left of the staircase, all of these are considered metals. And so, those are considered metals. So are these on the bottom here. These are metals as well. And so, go like this to show that these are all metals. Everything to the right of the staircase, those are non-metals. All right, so these are non-metals. So I'll put NM for non-metal, and I'll put M here for metal. Now notice there is one element that I did not highlight, and that is hydrogen. Because even though hydrogen is to the left of the staircase, it is actually considered a non-metal. So that is the one exception, and you do need to know this exception. It will come up a lot. So we have metals and we have non-metals. Very important. Everything to the left is a metal, everything to the right is a non-metal. Now let's go ahead and take a look. I want you to pause the video, and I want you to find all of these on the periodic table here. And I want you to tell me if they are metals or non-metals. Now let's go ahead and take a look at the periodic table. If you take a look, I've circled where all of those elements are. You can see that carbon, silicon, and hydrogen, those are all non-metals. And then we have tin, which is Sn, we have Nb, and we have Na. Those are metals. And so we can write metal, 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 non-metal, non-metal, metal. Now, I actually made a mistake there, and I want you guys to think, what mistake did I make? There's actually one that is wrong. And the answer is the carbon is wrong. Carbon is actually a non-metal. So, again, metals are to the left of the staircase, non-metals are to the right, hydrogen is the exception. Now, a compound is a pure substance formed from the combination of two or more elements. Another word for the process of combining chemically is bonding. So when we talk about bonding, two atoms that bond together, they are chemically bonding together. Bonding occurs because all atoms try to have a full outer shell to be stable, and atoms will lose, gain, or share electrons in order to do so. So again, they want to have a full outer shell. They want to have 8 valence electrons. They want to have 8 valence electrons, and so they will lose, gain, or share electrons to get that 8 valence electrons. So let's go ahead and talk about the 3 types of bonding. We're really going to focus on 2 of them, but there's 3 of them that we will deal with. So ionic compounds are between metals and non-metals. All right. Covalent compounds are non-metal and non-metal, and metallic is a metal and a metal. So those are the 3 types of bonds. Now in ionic compounds, electrons are transferred. Very important, they're transferred. They are lost or gained by other atoms. And metals will lose electrons, non-metals will gain electrons. And so this is what we're gonna focus on today. We're actually focusing on ionic compounds today. And it has to do with the transfer of electrons. Now, some properties is they're brittle, which means they're easy to break, and they have like kind of like peanut butter brittle. They have a high melting point, and they are electrolytes. And electrolytes are anything that conducts electricity when dissolved in water. All right, more on electrolytes in the future. Covalent compounds. Now, ionic compounds will transfer electrons, very important. But covalent compounds, they do something different. They share electrons. Electrons are shared because sharing is caring. And these tend to have low melting point, and these are non-electrolytes, which means they do not conduct electricity when dissolved in water. All right, so metallic bonds are a little bit different. We'll talk about those later again in a future video. But metallic bonds that are said to have a sea of electrons. They're said to be a sea of electrons. And electrons, they kind of float around from one metal to another. So if you think about your sink, which is shiny, it's got some metal in there. The metals are free to move throughout the whole metal structure. And that movement of electrons is actually what electricity is. And so these are malleable. And they are ductile, which means that you can form a wire with them. And they conduct electricity. So, now let's go ahead and identify if this is a ionic, covalent, or metallic bond. The first element, well, carbon, if you look at your periodic table, is a nonmetal. Sulfur is a nonmetal. A nonmetal plus a nonmetal is a covalent compound. So we're going to learn later that those two elements will share electrons. Now, magnesium is a metal. Phosphorus is a nonmetal. Again, you look at your periodic table to determine that. And a nonmetal or a metal and a nonmetal makes an ionic compound, an ionic bond. So electrons will transfer between them. Now, copper is a metal. Zinc is a metal. This is a metallic bond, and in this situation, the electrons are free to move around from atom to atom. And then we have this last one. Hydrogen is a nonmetal. Again, it's that exception. Even though it's to the left of the staircase, it's a nonmetal. And then oxygen is a nonmetal as well. And so this is a covalent compound. So just a couple things. Metals will lose electrons and nonmetals will gain electrons, and so that's something that we have to think about. So when something loses electrons, for example, sodium has a valence electron. When it loses that electron, it's losing a negative, so it becomes positive. Now chlorine has 7 valence electrons. It is going to gain an electron. And when it gains that electron, I'm going to go ahead and put X here to show the one that's gaining. When it's gaining a negative charge, it becomes negative. So what ends up happening is sodium becomes positive, chlorine becomes negative, and what do opposites do? Opposites attract. And so the sodium, the positive sodium cation, is attracted to the negative chloride anion. Now, just to brief recap here, an ion is anything that has lost or gained electrons. And so it can be a single atom or a group of atoms, which we will learn about later. But again, an ion is anything that's lost or gained electrons. Essentially, it's anything that has a charge. Now, cations are positive because cats have paws. Anions are a negative ion. So anions are negative. And so when we're labeling the following, this is P3 negative, so it is an anion. Now this right here, notice how there's nothing, there's no charge. That means it doesn't have a charge. So it is not a cation or an anion. It is neither. Now this here has a negative charge, so again it's an anion. And then this has a positive charge, so it is a cation. And there we go. Now, whenever we're writing compounds, ionic compounds, we always write the metal first. So we always write the positive cation first, and then we write the negative anion second. Now, something to keep in mind, covalent bonds do not have cations or anions. Instead, they share their electrons, and we'll talk about that more later. Now let's go ahead and turn to the back of our periodic table. And I want you to actually write this on your periodic table. Just a reminder, everything in the first column makes a 1 positive charge. Everything in the second column makes a 2 positive. Everything in the third column here makes a 3 positive. Now, the noble gases do not make a charge because they already have a full octet. The halogens make a 1 negative, these make a 2 negative, and these make a 3 negative. Now what I'll say is these right here, we'll talk about those later, but the reality is these down here, we're going to say these can make a 4 positive. So for now we'll say that. We'll address more of that later. These here, don't worry about what those make. So for now, just worry about the columns that I told you just in this moment. So let's go ahead and do some practice here. So if you take a look, this right here is a metal and a non-metal, so it is an ionic compound. I'm just going to put I for ionic. This here is a non-metal and a non-metal. That is a covalent compound. This is a non-metal and a non-metal. It is a covalent compound. And then this is a metal and a non-metal. It's an ionic compound. Now what we're going to do is we're going to write the cation and anion for each. So the cation is the positive ion, the anion is the negative ion. And so if we take a look at aluminum here, you'll see that aluminum makes a 3 positive charge. So that is the cation. And then we have sulfur makes a 2 negative, that's the anion. And so the way we write that is like this. Again, aluminum is the cation, it's Al3+. Sulfur is the anion, it is S2 negative. And that's how we write it. Now what about this next one here? Well, if you look at your periodic table, hydrogen makes a 1 positive, oxygen makes a 2 negative, except, what does this say? Covalent compounds do not have cations or anions. So if it is a covalent compound, you write not applicable for both. Very easy, because it does not have a cation or an anion because the electrons are not transferring, instead they're sharing. We'll talk about that in the future. Not applicable. Not applicable. And so again, if it's a covalent compound, does not have anions or cations. But what about this next one? Well, we have magnesium and oxygen. And if you take a look, it's magnesium, oxygen. And so magnesium is a 2+, oxygen is a 2-. So we write Mg 2+, O2 negative. So let's go ahead and review how atoms gain or lose electrons. Now, we did talk about this last unit, but lithium has 1 valence electron, and again, it can either gain 7 or lose 1, and I'm telling you, it's going to lose the 1. Essentially, metals will lose all of their valence electrons, while nonmetals will gain however many they need to get 8. And so again, lithium is going to lose its 1 negative electron, and when it loses 1 negative electron, it becomes a 1 positive. Magnesium has 2 valence electrons. It will lose those 2 valence electrons and become a 2 positive. And then finally we have aluminum, which has 3 valence electrons. It will lose those 3 electrons to become 3 positive. All right, let's talk about nonmetals now. Fluorine has 7 valence electrons. Now what it will do to get 8 is it'll gain 1. And when it gains that 1 negative electron, and I'm putting an X just to show you it's the one it gained, so it's not any different than the others, it becomes a 1 negative. Because again, it's gaining a negative charge, and oxygen has 6 valence electrons. This one will gain 2, become a 2 negative. Chlorine, again, has 7, just like fluorine. It will gain 1 electron and become a 1 negative. So again, however many valence electrons a nonmetal has, it will gain whatever it needs to get 8. For metals, it will lose whatever it needs to not have any. So let's go ahead and put these two concepts together. Again, let's think about this. These are losing electrons, these are gaining. How does that work? Well, let's take a look. So we have a lithium atom. So we're taking a look at this next page here. We have a lithium atom. A lithium atom has 1 valence electron. And a fluorine atom has 7 valence electrons. Now lithium wants to lose an electron. Lithium wants to lose 1, and fluorine wants to gain 1. When this loses its electron, it's going to lose it to fluorine, to where fluorine will gain the electron. And what ends up happening is lithium then makes a 1 plus, and fluorine then makes a 1 negative. And notice how these charges actually balance. And I'm going to fix this real quick, just because it's bothering me. It's 1 positive. So notice how the charges balance, all right? And so what we end up with is lithium loses the 1 electron and fluorine will gain the 1, becomes a 1 plus and 1 minus. This is 1 lithium for every 1 fluorine. And we end up with a 1-to-1 ratio, which is LIF. This is a 1-to-1 ratio. Now magnesium, let's take a look. Magnesium has 2 valence electrons. Oxygen has 6. This wants to lose 2. This wants to gain 2. It's perfect. This will lose an electron here, so this will gain it. This electron will be lost over here, and this will gain it. And what we end up with is magnesium, which has lost 2 electrons and has become a 2 positive. And then oxygen, which has gained 2 electrons and has become a 2 negative. Notice how that worked out perfectly. Notice how it is, again, a 1-to-1 ratio, and it'll make more sense on this next one. But 1 magnesium will lose both of its electrons to 1 oxygen, and so we end up with a formula of MgO. All right, this next one is where it'll be a little bit different. So we have aluminum, and we have 3 valence electrons. I'm just going to put them on the side here just so that it just works out better with transferring. Now, chlorine has 7 valence electrons. And I'm going to pick a different color here. So chlorine has 7 valence electrons. How many electrons does chlorine want to gain? Chlorine wants to gain 1. But aluminum wants to lose 3. So if chlorine gains 1 but aluminum loses 3, how does that work? Well, let's just go ahead and transfer 1 over. So this goes here, and we end up with it gaining 1. And this becomes a 1 negative when that happens. But we have these 2 here that still need to be lost. And what ends up happening is we have more than 1 chlorine. It will require another chlorine . But yet, it's still not enough because look, there's that one. So we need another chlorine. And this will transfer over here. And so notice what ends up happening here. Notice how the aluminum, because it loses 3 electrons, becomes a 3 positive. And notice how chlorine, each chlorine becomes a 1 negative because each one has gained 1. Notice the ratio in this situation. This is a 1-to-3 ratio. 1 aluminum will lose electrons to 3 chlorines, and so it requires 3 chlorines to accept all 3 aluminum electrons, all 3 of aluminum's valence electrons. And so the formula that we would end up writing is Al1, we don't need to write the 1, Cl3. So it's aluminum chloride, and it's AlCl3. So again, notice the the 1 to 3 ratio. Now, something to keep in mind is notice how the charges actually balance as well, and that's actually going to be the trick we use later. But aluminum makes a 3 plus, chloride makes a 1 minus, and so you will need 3 chlorides to balance with the 1 aluminum. All right, so let's go ahead and let's do this next one here. Now this next one, let's go ahead and look at lithium and sulfur, and we're going to work backwards here. So let's say we had lithium and we have sulfur. And if we look at our periodic table, you'll see that sulfur makes a 2 negative. You'll see that lithium makes a 1 positive. And so this makes a 1 positive, this makes a 2 negative. And so how do we balance the charges in this situation? Because again, it's going to come down to how do we balance these charges? This is a 2 negative, that's a 1 positive. Well, the way you do that is by adding another lithium. Because again, this right here will end up balancing that. And so let's see how that works. We have lithium, which has 1 valence electron. We have sulfur, which has 6 valence electrons. This lithium will lose this, the sulfur will gain it, but the sulfur still wants to gain another one. And so we need a second lithium here to transfer its electron to come here. And so that's how it happens. So the lithium loses its electron to sulfur, and we end up with Li2S. All right, so let's go ahead and do the same thing. So we have magnesium and chlorine. So here we go. We have magnesium, we have chlorine. Magnesium makes a 2 plus, chlorine makes a 1 negative. And so if you take a look, how do we balance the charges? Well, this is a 2 positive, this is a 1 negative, so what do we need another of? We need another chlorine. Because look, now the charges are balanced. And let's go ahead and again take a look at how that works. So we have magnesium, which has 2 valence electrons. It wants to lose those 2 electrons. And so it's going to lose one here. It's going to lose another one here, to where each chlorine will end up gaining 1 electron. Because again, chlorine has 7 valence electrons, it only wants to gain 1. And so we end up with a final formula of MgCl2. And that's magnesium chloride. All right, pause the video, do these last 2, and when you are done, play the video to see if you got the right answer. All right, potassium. Potassium is right here, makes a 1 plus charge. Bromine is right there, makes a 1 negative. And so potassium is a 1 positive, bromine is a 1 negative, and so because it's a 1-to-1 ratio, because they're already balanced, it's a 1-to-1 ratio. And so we end up with KBr. And the way that works is potassium has 1 valence electron, bromine has 7. Again, bromine wants to gain the 1, so it goes like this. All right, last one, aluminum and sulfur. All right, this is going to be the hardest one. This is the hardest one. So we have aluminum, which is 3 plus. We have sulfur, which is 2 negative. So this is actually a hard one. So we have aluminum, which is 3 plus. We have sulfur, which is 2 negative. How do we balance that? And so again, pause the video. If you haven't already done so, pause the video and see how you can balance it. This is going to be the hard. If you can do this one, you can do all of them. Well, the way it works is, notice how this is a 3 positive and this is a 2 negative. So we need more negative because the negative is not enough. So we add another sulfur here. But then it's too much negative. So what if we do this? What if we had 3 of these and 2 of those? Do you see how that actually would balance it? Notice how the aluminum was a 3 plus. Each one makes a total of 6 plus. Notice how the sulfur is 2 negative, and each one all together makes a 6 negative, so it's balanced. And so the formula here will end up being Al2S3. And so let's take a look at how that works. So we have aluminum, which has 3 valence electrons. We have sulfur, and I'm going to pick a different color here. Sulfur, which has 6 valence electrons. And so this will lose one. So sulfur wants to gain 2. So aluminum will lose 2 of them, but then it still has this one left over. And that's where the next sulfur comes in. And so this will transfer over here. But this still wants to gain 1 more, because again it wants to gain 2, but it's only gaining 1 now, and that's where we have the next aluminum, where it has this electron coming over here. And I know this is getting messy. So what we need to do is, because there's 2 more electrons there to transfer, we need to have another sulfur here, where one of these goes here, and the next one goes here. And I know it's a lot going on. But this is what I want to say. You do need to understand how the electrons transfer. In an ionic compound, electrons transfer. The metals will lose their electrons, and non-metals will gain their electrons. But if you were wanting to come up with just the formula here, you actually don't need to do this whole thing right here. What you can do instead is just balance the charges, because if you can balance the charges, you will always figure out what the right formula is. I know that was a lot going on there, and I'm sorry the video was so long, but it was necessary to make sure that we get the content needed. Definitely come to class with some questions, and I hope y'all have a great day.